Can you solve this algebraically? Okay, so I'm going to show you a step-by-step method where we need to isolate the variable by performing some operations on both sides of the equation to maintain balance. So here we have an exponential equation and we need to use algebra to find what m is. Okay, so first let's take note of this law of indices. So when raising a power to another power, you simply multiply the exponents. So you would multiply m by n to get a to the power of mn. So here we are given 3 to the power of m, and we are going to be creative. We're going to raise all of this to the power of 2 over 2. Notice we have not changed the value, it is still the same. Minus, we are given 2 to the power of m, and we are going to do the same. So raise to the power of 2 over 2, all equal to 65. Now, if we now rearrange things a bit, so raise 3 to the power of m divided by 2, and then square it, again, it is still the same value. We have not changed the value. Minus, if we do the same for 2 raised to the power of m divided by 2 and then square it, at this point notice something. We have a squared thing subtracted from another squared thing. We call this a difference of two squares. So for example, a squared minus b squared can be factored as a plus b bracket a minus b. Now, next. Let a be equal to 3 to the power of m divided by 2. And let b be equal to 2 to the power of m divided by 2. And remember, our difference of two squares are equal to 65, right? So here, some people will say, I know 65 is equal to 13 times 5. So therefore, the bracket a plus b must be the one equal to 13. And the bracket a minus b must be the one equal to 5. Although this worked on this question, you will see in a minute, it's not always reliable to assume this on other similar questions. So here we end up with two simultaneous equations. And if we try to solve them, say, for example, subtract the second equation from the first one, we get 2b is equal to 8. So therefore, b is equal to 4. And if we now substitute b in one of the equations, we get a is equal to 9, right? Do you know what would be reliable to work out the values of a and b? Okay, so this is what we have, right? This is the same. It is to use square numbers. So now let's start with 1. So we know 1 is a square number, right? So let b be equal to 1. And if we substitute b is equal to 1, we get a squared minus 1 squared is equal to 65. So therefore, a squared will be equal to 66. Now, 66 is not a square number. So really, we cannot use b is equal to 1. That's fine. Now let's try the next square number, which is 4. So we can let b equal to 4. If we substitute b equal to 4, we get a squared is equal to 65 plus 16, which is a squared is equal to 81. So therefore, a will be equal to 9. Right. Now, next. Remember, we let a equal to 3 to the power of m divided by 2. And we now know the value of a. It is 9. So 9 is a power of 3. It is 3 squared. Since here we have the same base, we can equate the powers and solve for m. So therefore here, m will be equal to 4. Okay, we can also double check with b too. So remember, we let b equal to 2 to the power of m divided by 2. We know b is 4, So as a power of 2 is 2 squared, equating the power m is also equal to 4. Now, let's substitute our answer. So originally, this is what we had. So if we now substitute m with equal to 4, we will get 3 to the power of 4, it is 81, minus 2 to the power of 4, it is 16. So 81 minus 16, it is indeed equal to 65. So m, it is 4